Welcome to Mathenatic. In this video, we'll find the first derivative of fx from first principles, where fx is equals to the root of 2x plus 5. So before we start, I can let you know already this is quite a lengthy solution, so please bear with me as we go through it step by step. So to find the derivative from first principles, we'll use the equation of the limit of h towards 0 for fx plus h minus fx over h. So to find fx plus h, I would substitute the x in my equation with x plus h. And I'll do that substitution in brackets. So when I do that, we have the limit of h towards 0 for the square root of 2x plus h plus 5 minus fx, which is simply the square root of 2x plus 5, and I have this over h. Now our next logical step is to remove the brackets. So we'll multiply 2 with x and 2 with h. So that becomes the square root of 2x plus 2h plus 5 minus the square root of 2x plus 5 over h. So this is where the mathematics gets a little bit messy, because I cannot remove these square roots and I cannot substitute h with 0 because then the fraction would be undefined. What I need to do is find a way to get rid of the square roots in the numerator. And how I do that is I would multiply the whole fraction with another fraction. And I'll multiply it with the square root of 2x plus 2h plus 5 plus the square root of 2x plus 5. And in the denominator, I'll have exactly the same. So I'll have the root of 2x plus 2h plus 5 plus the square root of 2x plus 5. So can you see I'm actually just multiplying by 1 because both the numerator and denominator is exactly the same, and therefore this is the same as saying 1 over 1. And what I'm doing is I'm taking the numerator in my original fraction and I'm multiplying it with itself, but I'm changing the sign in the middle from negative to positive. So I'm actually creating something that looks like a difference of 2 squares. And I hope that you know that when you multiply out a difference of 2 squares, the middle terms will cancel out and we'll have the first term squared minus the second term squared. So when I multiply out these numerators, I'll actually have removed the square roots. So let's quickly do that now. We have this is equal to the limit of h towards 0 for 2x plus 2h plus 5 minus 2x plus 5 in brackets. And then in my denominator, I still have the denominator with the roots. So we'll have h times the root of 2x plus 2h plus 5 plus the square root of 2x plus 5. So can you see that because this creates a difference of 2 squares in the numerator, what we are actually just doing is removing the square roots. So the square root times the square root becomes whatever is inside of that square root. So that first term would simply become 2x plus 2h plus 5, and my second term squared simply becomes 2x plus 5. Notice that I'm using brackets. So when I simplify further, I'll have the limit of h towards 0 for 2x plus 2h plus 5 minus 2x minus 5, because I'm distributing this negative 1. And this is over my messy denominator of h times the root of 2x plus 2h plus 5 plus the root of 2x plus 5. And I close that bracket. Now in the numerator, I can cancel out the like terms, so I'm simply left with 2h. And what you can see is that if I'm only left with 2h, that the h's would cancel out. So essentially, I'm only left with 2 in the numerator. So this becomes the limit of h towards 0, where we have 2 in the numerator, and in the denominator, we have the square root of 2x plus 2h plus 5 plus the square root of 2x plus 5. So remember, the h is cancelled out, so I'm not concerned about that anymore, and I have cleaned up my numerator. Now I can safely substitute h with 0, because it won't make the whole denominator 0, it will simply make this middle term 0. So when I do that, we have 2 in the numerator, and in the denominator we have 2x plus 5 plus the root of 2x plus 5. And can you see we have two terms that are like terms? So this is the same as saying 2 over 2 times the root of 2x plus 5. And now the 2's will cancel out as well. And that simplifies to 1 over the square root of 2x plus 5. And that is the derivative of the square root of 2x plus 5. It simply becomes 1 over the square root of 2x plus 5. Notice that I keep the limit in front of my fraction up until the point of substitution. And I cannot substitute h of 0 up until this point because it will make the whole denominator 0, which is undefined.